Hey guys, we're going to do a quick review on how to read and use the periodic table so that maybe you can study a little bit for our quiz tomorrow. So here's a tile just taken off the periodic table. This is carbon. So we know that this is called the chemical name. The C is the abbreviation. This is the chemical symbol. Okay, 6. I'm going to give you a second to try to figure out what the 6 stands for. This is the atomic number. This is how many protons are in one atom of carbon. Now remember, for our purposes, protons and electrons are going to be equal, so 6 also tells you that there's 6 electrons. If you can hear a dog breathing, guys, it's because my big dog jumped there. So sorry about that. 12. Remember, we are going to round to the nearest whole number. So 12 right here, we would just use it as 12. This is the atomic mass. Atomic mass. Somebody tell me how you find atomic mass. It is protons plus the neutrons. So if I ask you to draw a Bohr model and I just give you mass and the atomic number, remember that we can subtract the number of protons from the mass and get the neutrons. Okay, so again, this is the atomic number, the number of protons. This is the atomic mass, or AMU, the atomic mass unit, and it is 12. This is the protons and the neutrons combined. Now for the periodic table. These are all of our elements. For some of the patterns that we figured out, remember, we just figured out that this is the atomic number. Hydrogen has 1 proton, then we go to 2, come back 3, 4, 5, 6, 7, 8, 9, 10. Okay, so one pattern, they all go up by atomic number. With every element you get, you add 1 more proton to the nucleus. Second pattern, here's our mass again. It's around 1, helium around 4, lithium around 7, beryllium around 9, boron around 11, carbon around 12. So there's no set number, it increases by. However, every element's mass increases as you go along the table. So, do we remember what the columns are referred to as? They are called groups. Another word for them are families. So this very first column, this is group 1. Group 2, 3, 4, and then all the way down to our last group over here. This is group 18. We talked about 5 specific names of these groups. Our first group name is alkali metals. Group 2 special name is alkali earth metals. So remember, the way that I said you can remember that is alkali metals only has 1 name in front of metals, it's group 1. Alkali earth metals has 2 names and it's group 2. Now we have all these guys in the middle from group 3 to 12. These are your transition metals. You're transitioning from the superreactive metals over to your metalloids. Uh-oh. Wake up, computer. Okay. Group 17 is the other one that we learned. These are your halogens, fluorine, chlorine, bromine. Brought me a dog toy. Iodine, astatine. Then these very last guys, these are the only ones who naturally have a full outer shell with 8 valence electrons, so we call them the noble gases. These are all gases. Okay, if you remember, another pattern was that your group number is going to end up telling you how many valence electrons that element has. So group 1, remember, they all have 1 valence electron. Group 2, they all have 2 valence electrons. Then we come over here, group 13. Well, you can't have 13 valence electrons because remember, our electron rule is 288. So 13 actually has 3, 14 has 4, 15 has 5, 16 has 6. You just take the 1 off of your group number. That's how many valence electrons. So we have 7 valence electrons and 8 valence electrons. Okay, we're almost done. So we also, you can see they go across in rows. We call these rows periods. Period names are way easier. Period 1 just has hydrogen, helium. Period 2, lithium, beryllium, and it continues over here. Period 3, sodium, magnesium, continues this way. Then period 4, 5, 6, and 7. So on your periodic table, you should have written out the names here, period 1, period 2, period 3, all the way down to period 7. Then on the far right of your table, you should have drawn the pattern that we figured out. Now, if you don't remember or you don't have a periodic table in front of you, we decide the period determines how many energy rings does this atom hold. So hydrogen and helium in period 1 only have 1 energy ring. From lithium to neon, we have 2 energy rings. Then from sodium over to argon, we have 3 energy rings. So on all the way down, 4 energy rings, 5 energy rings, 6 energy rings, and then yes, even up to 7. If you have any questions, make sure to look at your notes, your periodic table. On the back of your periodic table, remember we also classified these guys right here as our metals. You need to remember the properties of a metal. They have luster, they're malleable, and they are conductors. We have our metalloids, who usually, there's a little staircase right here that show your metalloids. These guys are kind of the rebels. They don't go by the rules of metals or nonmetals. They kind of do their own thing. They have properties of both. And these guys over here are nonmetals. They are dull, they are insulators, and they are brittle. Hope this helps you guys study. Good luck.